Math 2, Module 2, Practice Problems 2.1 to 2.7, Page 2, Questions 6, 7, and 8. Graph each function. How is each function a translation of f of x equals x squared, right? So a translation of the parent quadratic function. If I have x minus 2, and that's occurring inside the argument, inside what's being squared with the x value, that is going to shift right 2 units. So instead of my vertex being at 0, 0, I'm going to go right 2. That's my new vertex. That's how I choose my middle point in my table. And I'm going to find the points around it. Several different ways I could do this. I could just do this based on my quadratic pattern, or I could plug in values and solve. If I plugged in values and solved, this would be 3 minus 2 squared is 1 squared, which is 1. If I'm at 3, 1, because of my symmetry, I'm also at 1, 1. 4 minus 2 squared is 2 squared, which is 4. If I'm at 4, 4, then I'm also at 4, 0. And that would be my graph. Looking at 7, this problem changes because it has a 3 added with the x instead of subtraction. So this time that is a shift in the opposite direction. So instead of going right, we're going to go left 3 units. And it has a subtract 4 on the outside, so that would be a shift down 4 units, making the vertex left 3 down 4 occur at negative 3, negative 4. Finding points around here, again, I could plug in table values and get it like that. This time, again, no leading coefficient here, so I'm going to follow the quadratic pattern. 1 squared is 1, so from my vertex, up 1 over 1 in both directions would give me points at negative 2, negative 3, and negative 4, negative 3. Up 2, or I'm sorry, 2 squared is 4, so up 4 over 2. That's at negative 1, 0, negative 5, 0. 3 squared is 9, so I could even get one more point in on this side at 0, 5. This one would have been at 6, 5. And I get the shape of my quadratic. The nice thing about 6 and 7 is both of those equations were in vertex form. Unfortunately, that's not the case in 8. So the first thing I want to do is convert it to vertex form. I think 8 is the most difficult problem that we've had to graph yet. But stick with me on this. I know we can do it. So again, first thing I'm doing is trying to convert it to vertex form. I'm going to factor a negative 2 out of both of these terms so that I can start trying to do a perfect square. So factor out a negative 2, since that's my leading coefficient here. I would have x squared. A negative 2 divided by positive 2, this would be a minus 1x. I'm going to leave room to complete my square and still have this plus 2 on the outside. Making this a perfect square. Half of negative 1 is negative 1 half. Negative 1 half squared is positive 1/4. If I add 1/4 here, I have to subtract something on the outside to keep my equation balanced. However, because I did it into something that was multiplied by 2, by negative 2, I'm going to have to do 1/4 times negative 2 And if I subtract, that would be a negative 1/2. Again, how I got this was the fact that I added a 1/4 into something that was multiplied by -2. So this completes my perfect square. Again, half of -1 is a minus 1/2 squared. 2 plus a negative 1/2 would be 2.5 or 5/2. Again, this is really tough. If you got this, awesome job. If not, I wouldn't be panicked. You do need to know how to complete squares. We're going to be looking at that in a future section of this review. But let's graph this now that we have an equation. I know that my table values, I have a vertex at 1/2, 5/2. So I can talk about my shift. It's going to shift right half a unit and up 5/2 units. This negative is going to make my parabola open down. And the fact that it's multiplied by 2 is going to be a vertical stretch by a factor of 2. So over 1/2, up 5/2. This is my vertex. I'm going to pick points around that. So at 1 and 2, 0, -1, and I would plug this in to either equation to get points. So I'm going to actually use my standard equation because I think I'll be able to get points a little quicker that way. -2 times 1 squared plus 2 times 1 plus 2. 1 squared is 1 times -2 is -2 plus 2 plus 2. So this value is 2 at 1. And because if this is my vertex, I have symmetry. So at 0, I can plot 2 as well. And then at +2, -2 times 2 squared plus 2 times 2 plus 2. 2 squared is 4 times -2 is -8. 2 times 2 plus 4. 2 times 2 plus 2. So -8 plus 4 plus 2 is a -2. And I have my graph of my parabola.